Okay, so we're going to look at balancing equations. So for this, we need to make sure that the same amount of elements as in terms of atoms for each element are the same on the left-hand side of the equation over here, and also the right-hand side of the equation. So to do this, we're going to write out each thing for each side. So we can do this with a little table. Left-hand side, LHS, the element in the middle, and right-hand side. Okay, so the first thing is to identify our elements. So we see that there's sodium, there's sulfur, oxygen, and hydrogen. Okay, so we have all those there. Now, over here, do we see the little 2 there besides the sodium? So that means that there's 2 sodiums there. Over here on this side, there's also 2. Okay. Now looking at the other elements, we can figure out which one's which. So the sulfur, we have only 1 here and another 1. So we have 2 on the left-hand side, 1 here and 1 here, 2 on the right-hand side. Okay, then we're going on to oxygens. So I have 3 here plus 4. So in total on the left-hand side, I have 7. Okay, and then oxygens over here, I have 4, 2, and a 1. So I have 7 over here. Then if we look at the hydrogens, we have 2 here and 2 here. So we'll build that in. So looking at it, we need to check if it's balanced. 2 sodiums on each side, that's perfect. 2 sulfurs on each side, 7 oxygens on each side, and 2 hydrogens. So this is what a balanced equation looks like. We don't need to add in anything to balance the ratios from either side. So we can say that that is fully balanced. Okay? So that's what we're trying to aim for each of these, to have the left-hand side equal to the right-hand side. So we're going to look now at an example where it's not balanced. So again, we'll do up our little table. Left-hand side element, right-hand side. List the elements that are there: carbon, oxygen, and hydrogen. Okay, so let's take a look now. So carbon has 1 on this side, and we have 6 on this side. So there's already an imbalance there. Then we'll take a look at our oxygens. I have 1, 2, and another 1, so I have 3. I have 6 plus 2, which is 8. So again, an imbalance present there. The last one, hydrogen, I have 2 here and 12 here. So we can see it's not like the last one. We need to work with our ratios to try and make it balanced. So usually when we work with balancing equations, we leave oxygen and hydrogen last. That's usually because there's a water or an oxygen molecule within the reaction, and they're the easiest things to help balance the equation, so we can leave them to last. So we're going to focus on the carbon. So to get my right hand side equal to my left hand side, I'll need to multiply this side by 6. Okay, so if I do that, go up to my carbon up here, and I'll put a 6 here. What does that change? So that will change this number to 6 carbons over here. So now 6. But what it's also done is, what's 6 times 2? 12. So now we have actually 12 oxygens over here. Sorry, we have not 12. We have 6 times 2, which is 12. We also have this one over here. So we have 13. Alright, so the carbons are fine. Now we need to look at the hydrogens. Okay, so we have 2 at the moment and 12. So what I'll need to do over here is multiply by this by 6 to convert this side to 12. So I'll go with my blue again, and I'll put 6 in here. Okay, so we've got carbon and hydrogen done. Now let's see what we need to do, if we need to do anything with the oxygens. So 6 carbons, that's fine. 12 hydrogens each side, that's okay. So let's take a look at the oxygens. Over here on the left hand side, I have now got more than 13. I've got 6 times 2, which is 12 on this side, plus another 6. So I have 18 oxygens here. Okay, now for there to be 18 over here, I'm not going to multiply this by anything, even though it's got an oxygen in it. If I did multiply that by a certain number, let's say 2, then it would throw out my carbon and my hydrogens that I've already balanced. So that's why we leave oxygen usually to last, because we might have a handy little oxygen here on its own, which we can balance separately. Okay, so let's see. I need 18 oxygens. So I already have 6. So 18 take away 6 from this molecule here will give us 12. So I need to get a little 6 in here, because now in total I have 6 oxygens from this. 6 times 2, 12 oxygens. So I can change this down here now to 18. So double checking it's all balanced. 6 C's on the left hand side, 6 C's on the right. 18 in total oxygens on the left hand side, 18 on the right. 12 hydrogens on the left and 12 hydrogens on the right. So again, it's fully balanced. And it's always good to double check. Now, I want you to try and do this one yourself. So pause me now. But before, I just want to let you know that if there's a 2 outside the bracket, that needs to be multiplied in. So currently, there's actually 2 nitrogens and 2 times 3, 6 oxygens present already there. Okay, so make sure to regard that number if you're multiplying anything by any particular number over here. Okay, so pause and give this one a go. Okay, let's go for it. So left hand side, element right hand side. You can do up your table as usual. So I have the Pb, which is lead, nitrogen, oxygen, hydrogen and sulfur. I have one lead on that side, one lead on the right hand side. I have 2 nitrogens on the left hand side, 1 on the right hand side. 6 plus 4, which is 10 oxygens. And 7 over here. And then I have 2 hydrogens, 1 hydrogen, 1 sulfur, 1 sulfur. So, again, we leave the more common elements to last. For example, hydrogen, oxygen, and carbon if present. So we leave them to last. So what we can deal with is the PBs first. Check if they're balanced. They are. So we'll move on from them. Next we can look at nitrogens. So currently we have 2 nitrogens over here. So I need to multiply this guy by 2. So I'll put a 2 in there for the moment. Now we need to look at the sulfurs. Leaving oxygen, hydrogen to last. Sulfurs seem okay. They're balanced. Now we're going to look at hydrogens. There's 2 here, and because I multiplied this molecule by 2, there's now 2 here as well, so that's fine. We look at the oxygens. We have 6 plus 4, 10 that side, and we have 4, and 2 times 3 is 6. So that has now actually changed due to our other multiplications to 10. So it's fully balanced now. Okay. Lovely. So that's it done. Hopefully that makes sense. The bigger numbers here represent only ratios, so you're not changing the actual molecules that are present in any way. You're just doubling the amount that is present. So that's important. You're not actually changing the chemical formula at all.